Let's take a question of limit where we have the question like this: if fx equals a0 x to the power n plus a1 x to the power n minus 1 plus a2 into x to the power n minus 2, and this goes on until you have a to the power a n minus 1 into x to the power n minus n, that is 0. So that x to the power 0 is this itself. Yeah, plus you have a n. I mean, this term should be like x to the power n minus n minus 1, then n gets cancelled, you have only 1, so x to the power 1, and then you have x to the power 0, which is 1, because any number to the power 0 is 1. Okay, so if you have this, then you have to prove that limit x tends to a fx equals f a. That means the value which you get will be a function of a. Let's prove this sum. We start with the given function and we find the limit of that function. That means limit of fx we find out. Limit x tends to a. Limit x tends to a is limit x tends to a, and fx is the whole this portion, that means a to the power 0 x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2, plus it goes on, plus you have a to the power n minus 1 into x plus an, and bracket close. So all these can be written as separately, that means limit of first term, limit of second term plus limit of third term. It continues till the last term, and this comes from the fundamental limits theory. That means there is, if you have limit of fx plus phi x, that can be written as limit of fx plus limit of phi x. So using that theorem, we now get limit x tends to a. First you have a0 x to the power n plus limit x tends to a1 x to the power n minus 1 plus limit x tends to a2 x to the power n minus 2, plus it goes on. Then you have limit a to the power an minus 1 x plus limit x to here also x tends to an. Okay, so from this what do we get? Now is the time when we replace the value of x here. That means I replace x by a. So first term will be a0 into a to the power n plus a1 into a to the power n minus 1 plus a2 into a to the power n minus 2, plus it goes on till you have a n minus 1 into a plus this a n remains. So this statement which you get, you have all the term as a. So you can write this as a function of a, right? So you started with fx and you ended up with fa. That means it is proved that, therefore you can write limit or x tends to a fx equals fa. This has been proved.